At the end of this video, I hope that you can calculate the percentage composition of a given chemical compound. Chapter 7, Section 3, Percentage Composition. It is often useful to know the percentage by mass of a particular element in a chemical compound. For example, suppose the compound potassium chlorate, KClO3, were to be used as a source of oxygen. It would be helpful to know the percentage of oxygen in the compound. To find the mass percentage of an element in a compound, one can divide the mass of the element in a sample of the compound by the total mass of the sample, then multiply this value by 100. The mass percentage of an element in a compound is the same regardless of the sample's size. Therefore, a simpler way to calculate the percentage of an element in a compound is to determine how many grams of the element are present in 1 mole of the compound. Then divide this value by the molar mass of the compound and multiply by 100, as is shown on the screen now or on page 227 of your text. The percentage by mass of each element in a compound is known as the percentage composition of the compound. For the next example, we will be using iron oxides. These are compounds that are composed solely of iron and oxygen, but in different proportions. For one example, we will be referring to iron 3 oxide, which has a chemical formula of Fe2O3, and iron 2 oxide, which has a chemical formula of FeO.
The percentage composition of a compound is the percentage by mass of each element in that compound. Iron, for example, forms 2 binary compounds with oxygen. The percentage composition of one is 30.1% oxygen and 69.9% iron. The percentage composition of the other is 22.3% oxygen and 77.7% iron. Because of their differing percent composition, their properties differ. To find the percent composition, divide the mass of a given element in a sample of a compound by the total mass of the sample and multiply by 100. The percentage composition can be used to find the empirical formula of an unknown compound. For example, we discover that an unknown compound is 69.9% iron by mass and 30.1% oxygen. If we took a 100-gram sample of this compound, 69.9 grams of it would be iron and 30.1 grams would be oxygen. We can convert this to moles and divide both by the smaller number of moles. This gives us the relative proportions in moles. To find the simplest whole number ratio, we multiply by 2. The empirical formula for this iron compound is Fe2O3.
As is evident by sample problem 7-10 and 7-11 on pages 227 and 228 of your text, it is clear that calculations involving percent composition can be multi-step. In order to give yourself the resources that you need to make sure that you can perform any problem involving percentage composition, including those which we haven't covered yet and will start to be covered in section 4 of this chapter, please take down the conversion factors shown on the screen now. At this point, I hope that you can calculate the percentage composition of a given chemical compound.